Now, I told you the conditions. Then, what is the total force? I write here. Total force acting on the system. Total force or the net force which is acting on the system. Definitely, first I write F vector is equal to, you look, F12 vector plus F1 vector plus F21 vector plus F2 vector. Just try to follow me. What I have written. What I have written, just try to follow. I have written here, this is the total force on the M1. This is the total force on M2. Total force on M1 में क्या क्या आएगा? External force plus internal force. Total force on M2 में क्या आएगा? Internal force plus external force. Understood? That means how much we are getting? Can I write it? F1 vector plus F2 vector. मैंने external force को अलग से लिख दिया. Plus F12 vector plus F21 vector. इनको मैं अलग से लिख दिया. ये मैंने क्या किया? सेपरेट कर दिया. These are the two external forces. These two are the internal forces. Okay? They have been separated. Okay. We know that F12 vector is equal to minus F21 vector. From where? Newton's third law. Action and reaction. Mutual force, action and reaction. Which will imply F12 vector plus F21 vector is equal to 0. So, F vector should be equal to F1 vector plus F2 vector. I hope you got these two internal forces. The sum of these two internal forces will be equal to 0 because these two forces are equal and opposite in nature. We are getting this. F vector, capital F vector, that is the net force, that is equal to the external forces, sum of the two external forces, F1 vector plus F2 vector. Then what we can write here? We can write here in this, see, it is M1 d square R1 vector, d square R1 vector by dt square plus, or better you write, I first write it, M1 A1 vector plus M2 A2 vector by Newton's second law. Then what is this? F vector is equal to, this F vector must be equal to M1 d square R1 vector by dt square plus M2 d square R2 vector by dt square. Can be written like this also. See, this is acceleration. I hope you all are remembering from our discussions of kinematics, We can write this, or we can write it in this way: F vector, थोड़ा सा mathematical rearrangement, d square by dt square M1 R1 vector plus d square by dt square M2 R2 vector. We can write this also. That means this is equal to how much? F vector is equal to d square by dt square M1 R1 vector plus M2 R2 vector. It can also be written like this. Just check it how I am proceeding. Please check it how I am proceeding and how the mathematical steps are written, just one after the another. Then we can write this is equal to F vector is equal to, here if I consider the total mass of the system, I can write it M1 plus M2 together d square by dt square m1 r1 vector plus m2 r2 vector by m1 plus m2. Very well, it can be written. No problem is there. I can write it in this way. Look how I have written. You can take it in this way also. This whole thing is together. Just watch it. What I have done. M1 plus M2 with M1 plus M2, that is the mass, total mass of the system. With this total mass of the system, I have multiplied it. I have divided it also. Then what it becomes? Force is equal to the total mass into acceleration of the system. Total mass into the acceleration. Now you just go back to our definition. What is center of mass? Center of mass is the point where the whole mass of the system is supposed to be concentrated. This whole mass of the system is concentrated where? At the center of mass. That's why I will write it here. It is m1 plus m2 into d square r vector by dt square. I write it like this, r vector. I say here, what is r vector? R vector is equal to m1 r1 vector plus m2 r2 vector by m1 plus m2. What is this? This is the position vector of the center of mass of the system. Look, it is the position vector of the center of mass of the system. मतलब हुआ, मैं इसे कंसीडर करता हूँ, it will be somewhere here. It will be r vector. Here will be center of mass. This is the point I am getting. See, in case of the two particle system, in the two particle system ultimately, but mind this, the position vector which I have got here, that is in the vectorial form, isn't it? Now what we can do, if it is in the vectorial form, now we can do something in this. What we can do? First thing, I just tell you one point here, that is, although it has been done in our syllabus, it has been done for the two particles, but it can be extended for a n number of the particles. Okay, so it can be extended for small n number of particles. How much it will be? R vector is equal to m1 r1 vector plus m2 r2 vector plus dot up to mn rn vector by m1 plus m2 dot up to mn. Look, let us suppose there are n number of particles, say m1, m2, m3 as so on up to mn. I just tell you, suppose there are n number of particles and their position vectors are r1 vector, r2 vector and so on up to rn vector. Then it will be like this. So what I said, normally or in your examination it will always be asked for two particle system, but you can extend it in case of the n number of the particles very easily. इसको तुम n नंबर ऑफ पार्टिकल्स में इजीली एक्सटेंड कर सकते हो. हालांकि ये एग्जाम में तुम्हें पूछा जाएगा ओनली टू पार्टिकल सिस्टम के लिए, बट इट कैन बी एक्सटेंडेड अप टू n नंबर ऑफ द पार्टिकल्स. नो प्रॉब्लम इन डूइंग दैट. ओके, नाउ व्हाट यू कैन डू हियर. इसके बाद अगर मैं यहां पर ये r1 वेक्टर r2 वेक्टर ये जो है इनको मैं अपने कंपोनेंट्स में अगर इसको कर दो तब क्या होगा? हाउ इट विल बी टेकन इनटू देयर कंपोनेंट्स. दे कैन बी रिजॉल्व्ड इनटू देयर कंपोनेंट्स आल्सो, इजंट इट? तो दे कैन बी रिजॉल्व्ड इनटू देयर कंपोनेंट्स. तो उसको मैं निकाल सकता हूँ। कंपोनेंट्स में रिजॉल्व करने के लिए मुझे क्या करना पड़ेगा, ये तो पूरा डेरिवेशंस हो गया, ठीक है। एंड नाउ वी कैन रिजॉल्व इट इनटू देयर कंपोनेंट्स। ओके।